This section is problem solving with algebra. One thing that we might look at in elementary school with algebra is the idea of a balancing scale. So here's a problem we'll answer at the end of the section. A whole brick is balanced with 3/4 a pound and 3/4 a brick. What is the weight of the whole brick? Algebra is a powerful tool that originated in Babylonia and Egypt more than 4,000 years ago. At first, there were no equations. They used words for variables such as heap and aha. A problem from the Rhine papyrus said heap and 1/7 of heap is 19. What is heap? So even without the idea of variables or algebraic symbols, they had algebra. Okay, let's note that the Common Core standards, which are not used in Texas but very similar to the TEKS, has algebraic thinking in first grade, and that's where you'll find it in the TEKS. And here we're just using the idea of an unknown. Okay, particularly think about those addition problems. 3 plus some number equals 7, where we might use a box or a car, an apple, or just some symbol instead of an X. It's still algebraic reasoning. A variable is a letter or symbol that is used to denote an unknown number. An algebraic expression is an expression containing algebraic symbols such as 2x plus 3 or 4x times 7x minus 5. And this will start in about 6th grade. The first thing I want you to be able to do is evaluate algebraic expressions for the variable h equals 14. So if I do 15 plus 3 times 14, that is 15 plus 42, which is 57. Notice that when we substitute 14 for h, we need to put the 14 in parentheses. The second one, I have two h's, so I have 14 plus 1/7 of 14. 1/7 of 14 is 2, and 2 plus 14 is 16. Okay, an equation is a statement of the equality of mathematical expressions. In elementary school, we use that balance scale model because balance is related to equality. The weight on the left side balances the weight on the right side. In this picture, there are 3 chips plus 5 chips equals 8 chips on the right side. So the sum of the left equals the number on the right. Equations and balance scales can be used to model a missing added end by using a box. So thinking what number must be added to the 5 chips on the left to obtain the 11 chips on the right. By removing 5 chips from the left side and the right side, that keeps the scale balanced. And then we see that the box would hide or replace 6 chips. Okay, I want you to solve 7x plus 2 equals 3x plus 10. You can use the balance scale model. I'd like you to be able to work through that, and also with equations. So if I made a balance scale, I'd have 7 boxes plus 2 chips on the left, 3 boxes and 10 chips on the right, and then you see the algebraic equation. First, I would remove 3 boxes because that is that there are 3 boxes on the right side, and there's the balance that I would get. And algebraically, removing 3 boxes is subtracting 3x from both sides. That is here and here. And then if I simplify, I get 4x plus 2 equals 10, and you can see that on both models. Okay, the next thing I'm going to do is remove 2 chips from each side, or subtract 2, so that I have no more chips on the left side. And I have 8 chips, or 8 on the right. Now that I have only boxes on the left, I can divide the number of chips by the number of boxes, so that each box represents 2 chips. I can do the same thing algebraically by dividing both sides by 4 to get 2. You can check that. If each box on the first scale is replaced by 2 chips, the scale will balance with 16 chips on each side. You can check that algebraically by plugging 2 back into the equation to see that 7 times 2 is 14 plus 2 is 16 on the left. On the right, 3 times 2 plus 10 is 16. So that shows that 2 is the solution. Okay, the properties of equality you will need to know to be able to substantiate why an equation, a step in the equation was valid. So we can add or subtract the same number from both sides. Number 2 says we can multiply or divide the same number on both sides. And number 3 is just to simplify, add, subtract, multiply, or divide. The National Council of Teachers of Mathematics, in their content standards, states the notion of equality also should be developed throughout the curriculum. Students should come to view the equal sign as a symbol of equivalence and balance. And most of the time we think of it, or students may think of the equal sign as the answer is coming. That's not what the equal sign means. So for example here, that means that h plus 1/7 h is the same as 19. If I'm going to solve this and substantiate each step with a property, the first thing you want to do, because there is a fraction, is to multiply both sides by the denominator. So that uses the multiplication property of equality by multiplying both sides by 7. When you distribute, you get 7h plus 1h. 7 times 19 is 133. The next thing we need to do is 7h plus 1h. That is just simplification. Then we're going to divide both sides by 8. That's the division property, and we divide both sides by 8 to get 16 and 5/8, or 16.625. And just doing that arithmetic is simplification. Okay, let's try that in a word problem. So Eleanor wins the jackpot in a marble game and doubles her number of marbles. If later she wins 55 more marbles, bringing her total to 127, how many marbles did she begin with? So if we work from the beginning and we say she had m marbles, she doubled her marbles to make 2m. She added 55 to get 2m plus 55, and we want that to total 127. So instead of just guessing, we can use algebra to write an equation. Then we can subtract 55 from both sides to get 72. Divide 72 by 2 to get 36. So she started with 36 marbles. Okay, let's look at inequalities, because those are also useful in math and daily life. John has $19 to spend at a carnival. The entrance fee is $3. Each ride costs $2. How many rides can he take? So you might start by making a table, $3 if he rides nothing, and then $2 for each ride he takes. So you can see the chart goes up by odd numbers and stops at 19 because that's all the money he has. Now you could do that with an equation or an inequality in this case, because he can't spend more than $19, but he could spend less than $19. So if I subtract 3 from both sides, I get 16. Divide by the 2, and he can take as many as 8 rides. An inequality is a statement that uses one of the following symbols, and it means that they're not equal to. One's less and one's more. We can still use the balance models for this. Just one side will be lower or higher than the other. So in this case, the 19 is the most he can spend, so the 19 on the right is the heavy side. To simplify that, I'm going to take 3 chips from each side. That's the same as subtracting 3. Then I have 2 boxes equals 16 chips. If I divide those 16 chips between the 2 boxes, that means that he can spend or ride at most 8 rides. Now I said that solving inequalities was almost like equations. So there is one spot where it's different, and that is if we multiply or divide by a negative number, we need to reverse the inequality. You can see that clearly on a number line. So we know that 3 is less than 8. Well, what would happen if I multiply or compare then negative 3 and negative 8? Negative 3 is not less than negative 8. They switch. So you can see that the inequality does need to change. So the three properties for obtaining inequalities are that we can add or subtract any number from both sides. We can multiply or divide by a non-zero number, and if the number is negative, we reverse the inequality. And then simplifying is still the same, just you're adding or subtracting, multiplying or dividing. So let's solve this inequality and state the property used. Okay, so for step 1, we would multiply those two, and that is simplifying. On the next one, I would want to move the 16, so I'm going to subtract 16x, just 16, which is the subtraction property. On the next part then, 52 minus 16 is 36. That is simplification. Then I'm going to divide both sides by 12. So since I'm dividing, that is the division property. To get the answer of 3, I'm just simplifying. You can display that answer on a number line by shading, so all the solution is the shaded part. Remember, 3 is a circle here is open because 3 is not included. All right, we have a manager at a garden center who wants to order trees. 138 trees, some Japanese red maples and some flowering pears. We have the cost of each maple tree and pear tree and the budget of $18,000. Here's the information from the previous slide. X is the number of maple trees, and we want 138 trees. So that means that the pear trees has to be 138 minus X. The cost of the maple tree was $156, and the cost of the pear tree was $114. That gives me the equation 156x, that's the maple trees, plus 114 times 138 minus x, that's the pear trees, is 18,000. Then if you distribute, combine like terms on the left to get 42, subtract 15,732 to get 2268 on the right, and divide, you'll get 54 for x. 54 is the number of maple trees. And now we're back to that problem we started with. If we know that a whole brick balances 3/4 a pound and a 3/4 brick, the first thing I would do would be to take 3/4 a brick from each side. That leaves 1/4 of a brick on the left equal to 3/4 of a pound. If 1/4 of a brick is 3/4 a pound, I need to multiply that by 4 to get a whole brick, which leaves me with 3 pounds. Now you're ready to start your homework on algebra. Thank you.